I'm covering the Gradebook application that I created and uploaded to the Blackboard site. It contains a class which is called Student. And what I did was I just sat down and I thought about, okay, what kind of information would need to be stored for each student in an object? And I decided that there was a first name, a last name, and again, since we haven't covered arrays yet, 3 grades as well as the student's average. Additionally, I have some methods here. There is what we call a default constructor. The default constructor initializes the first name, the last name, the 3 grades, and the average, the 3 grades to 0, and the first name and last name to the empty string. Um, the default constructor is sometimes called when you don't have all of the information for what we're going to talk about in terms of the overloaded constructor. The overloaded constructor has, or method, it's the same thing. Methods can be overloaded, constructors can be overloaded. It's the same named method, or in this case, constructor, but it has a different number or type of parameters, as you can see in this example. All right, so you can see that up above there is the student constructor. That's the default one. I know it's the default because it takes no parameters. The overloaded constructor takes 1, 2, 3, 4, 5 parameters. The first name, last name, and the 3 grades, and assigns them to the fields or instance variables. Since we still haven't calculated the student average, it still gets a value of 0.0. The next method is the calculate average method, which basically takes the 3 grades, adds them together, and divides by 3.0. It is really important to remember to divide doubles by doubles, otherwise they can potentially get converted into integers. All right, so if I just divide it by 3, there's the potential that that could be converted into an integer, thus meaning that the average was truncated, the decimal was truncated. I'm going to come back to update class information in a second. The next method that is in the student class is to display the information about the student. So I have the first name, the 3 grades, and the student's average. All right, then I have my typical accessor and mutator methods to get and set the first, last names, the 3 grades. I only put an accessor method in this class for the student average because I would never want to change the student average without performing the calculation first. It should always be calculated, and then I should just get it from the accessor method. All right, the other, as I said, I'm going to come back to the other method. The other class is the Gradebook App. I just call it Gradebook App. It's not really an app for an iPhone or anything like that. You're going to see that there's 2 variables here that are static. Remember from your reading and from the slides that static means that there is only one of these no matter how many instances are created. All right, so in the student class, remember each student is going to have a copy of first name, last name, grade 1, grade 2, grade 3. By making this static, there is only ever going to be, no matter how many gradebook apps I could create, there is only ever one number of students so far and one total calculated so far. These 2 variables are going to be used to calculate the class average. You can see that I also created a scanner. I made it static just to kind of continue on with the concept of static. Now, every single time that I start talking about static variables, and methods can also be static, people start wanting to make everything static. Let me just talk briefly about why this isn't a good idea. Number one, as I said, it only has one existence of this variable. So if I went back to the student class and I made each of these static, I could not have multiple students. I could only ever have one, right? Because there would only be one first name and one last name. And every time I instantiated or tried to change something in it, that one existence of that variable would change. So just like this, the one existence, every single time I modify this, the one existence is going to change in number of students so far. The other thing about static methods and static variables is that you do not call them via an instance of a class. You call them by using the class name dot and then either the name of the method along with the parameters or the name, in this case, of the instance variable. So class name dot name of method or class name dot name of instance variable. Okay? So remember down here we had a method called update class information. And you can see that every single time that I update the class information, I'm adding 1 to the number of students so far. All right, so every time that I add a student in and do their grades, it's going to display the information about the student and display the class average. The total calculated is the sum up to this point. All right? So you can see that I'm updating these by calling not an instance of Gradebook App, but the actual class name itself. That's a big distinction. As I said, please don't get carried away with making things static. Some people actually frown upon calling anything static in the object-oriented world because it sort of relates back to the times of global variables. And hopefully from Java 1 and any other programming classes that you've had or experience that you've had, you remember that global variables are very bad because they have side effects that are not always foreseen. The same, excuse me, the same thing can occur with static variables. All right? Now, the good thing about it is that by putting in the class name, you know that you're accessing a static variable, and you're sort of more aware of what's happening with it. Very often, you will see that static classes and static methods are associated with helper classes. For example, if you go back to the control statements program that we were looking at earlier, you'll notice that when I was doing the uppercase, where is it? Right here. All right, on line 173, when I was doing character.toUppercase, character is a class that's already defined in Java. It's predefined, and it has a static method called toUppercase, which takes a variable, which is a character, that needs to be converted to uppercase. So you're going to see that we do use these relatively commonly. So if you do things like parseInt, convert to double, toString, these are all generally static methods. ToString may be the exception there. All right, but whenever you're doing like capital D as in double dot convert to double or whatever it is, or convert to string or whatever the case is, remember that you're actually calling a static method. So we've already used one of these in the past, so hopefully it's not that foreign of a concept. But I just wanted you to be aware that they do exist and that you will see them from time to time, and, as in the case with the character class, you will be using them periodically. Okay? Now, this update information method gets called from every time that I calculate the student's average. I update the class information, which tells, again, that static variable to update the number of students so far by 1, and to add whatever this student's uh, average is to the total calculated. Notice that I'm again using the keyword this. This refers to the current object or the current instance of this class. All right, so I'm saying self, give me the current student average and add it to this total calculated so far static variable. All right. Remember, in order to define a static variable, you define it the same way as before. I made them public because I wanted to access them directly. The only difference is that you add in the static keyword along the line. All right, getting back to this, I have a prompt for the student's first name, which just has the system.out.print. You'll note that I'm using console.next versus next line. The only reason that I'm doing this is that I'm not entering in the student's first and last name on the same line. I'm separating them. And in order to avoid an issue with reading a new line character, which you don't need to really know about right now, what this does is this will read, next will read everything up to the space. All right, up to a space. So in this case where I'm entering a first and last name, it actually works out very nicely. All right, the next one that I have here is a prompt for student grade. And you're going to notice that it takes the grade number. So what this is going to say is it's going to say enter the student's first grade, enter the student's second grade, enter the student's third grade. So it's taking that as a parameter and returns the value that the user entered. Calculate class average takes those static variables that we talked about before, divides the total that's been added or summed up, and divides it by the number of students. Displaying the class average is just two system.out.println statements, which makes sense. You will note that main is always a static method. All right, so you always want main to be static. Then inside of main, the first thing that I do is I instantiate a Gradebook app. And then I go through a for loop. All right, so I'm going to assume that we're going to have 3 students in my for loop. So I'm going to repeat this information, prompting for the student's first name, the student's last name, and then the 3 grades. 3 different times. I'm assuming there's only 3 students in the class. Again, I start off with the for keyword, parentheses. The initialization, you can see that I'm using J in this case. So I'm going from 0 to 3. Remember that J++ only gets incremented after the statements inside the loop have been executed. All right, I call my prompt for the first name, prompt for the last name, and then I use a for loop to get the 3 grades. All right, so I declare 3 local variables, grade 1, grade 2, and grade 3, and initialize them to 0. I'm using a nested for loop to get the 3 grades. So for every 1 student, I'm getting 3 grades. You'll notice that I used I, and in this case I did I equals 1, I less than or equal to 3. That was to show you that there's different ways of initializing for loops. I don't have to always initialize something to 0 unless I'm dealing with an array, as we'll deal with next week. All right? So in this case, my counter is starting at 1, and it's going less than or equal to 3. I'm using a switch statement to decide which comment should be inserted, or which first, second, or third word should be inserted into the prompt for the grade. So if the loop is on the first one, it's going to send up first. If it's on the second, it's going to send up second. And otherwise, it's always going to send up third. Now that I have collected all of my 3 grades and the student's first and last names, I'm going to instantiate the objects. Right? In this case, I decided to use an if statement. So if the counting of the outer loop. Note, remember, this is the loop for the grades. This isn't the loop for the students. If the outer loop, which is the J loop, is equal to equal to 0 or 1 is equal to 0, I'm going to instantiate student 1. Right? So I'm instantiating student 1 by saying new student, the first name, passing in the variables to the overloaded constructor. The first name, the last name, and the 3 grades. If j equals 1, then I'm doing the first name and last name of the first student. All right? Now remember, j is starting at 0, so I had to change those two things to go from 0 and then 1. If j is equal to 2, then I'm obviously on my third student, and I'm going to instantiate that object with that student's first name, last name, and associated grades. All right. The last thing that I do for each one of them is I display the information about each one of them that's been collected or instantiated and passed in to the overloaded constructor. Remember, the overloaded constructor, the differentiation between them is the fact that this one is default, it has no parameters. This one is overloaded, it has a different number or type of parameters in it. All right. Then the last thing that I do is I display the class average. And again, that's just using those static those static variables, total calculated so far divided by the number of students so far, and it displays that. So when I run this, I want to save it. And I'm going to enter in the student's first name. I'll just put mine in. The last name. And I'm going to come up with 3 grades. 92.3, 67.8, and 85.4. All right, you'll see that it calculates, that it displays the my name, the 3 grades, and the student's average, in this case 81.83. I'll show you later on how to fix the truncation and, round up and all that stuff. Now I'm on to the second student. So in this case it's going to be Charlie Brown. Charlie Brown got a 100.0, a 99.2, and an 87.5. All right, you can see that Charlie Brown's average is a 95.57, and it has now changed the class average to be an 88.6. The last student that I'm going to enter in is Homer Simpson, and he got a 45.7, 89.2, and a 24.9. All right, and now you can see that it displays his average, and it also shows how his average influenced the class average. The last thing that I wanted to talk about in this example is the fact that we still haven't done much with packages. In your textbook and in the slides, they talk about the use of creating packages and why you do it. You create a package so that you can reuse these classes that you're creating in other programs. All right, so it's all about code reuse. We're going to do more of this next week. I wanted you to at least read about it and understand it a little bit before we started doing anything with it. All right, so for this week's assignment, continue to use the default package, and don't worry about the package names, but at least read about it inside of your textbook as well as in the slides. In this example, just as a recap, we talked about static variables, overloaded methods, um, and again, just provided another object-oriented design. The difference here is, note, we did create a second file. To create a second file, all you do is right-click on your package and select New Class. You're going to name it. Remember, only one Java file can have a main program in it. In this case, I always call mine something app. All right, so some of you are probably more familiar with using different classes to instantiate your test classes to instantiate the student class in this case. All right, and that's the way that we're going to be writing programs from this point forward. We're always going to have a separate class that uses the other class. Okay? Let me know if you have any questions on any of this. Again, all of the material that we covered is in the slides. It's in the book. So make certain that you're reading all of that as well. And let me know if you have any issues with it.